How many of you got to see the space station last night? Did anybody go out and look? It was pretty bright. Oops, that's something else. I'll show you that in a second. So hard to get a handle on what this is, but this is my from my driveway. That's the space station right there. It was super bright. That's the upstairs window at my house. All the other ones came out all crazy. iPhones don't do well in the dark taking pictures. And then I tracked it across the sky for a while, and I have an app called Night Sky. I don't know if anybody has heard of that before, but you just put the app on and then you just scan anywhere and it tells you what you're looking at. It's really cool. And there was the International Space Station riding Pegasus there with next to Orion. Orion, most people can find. But anyhow, I dropped a link to the NASA Spot the Station sign up if you want to do that. I just think it's cool. And it was definitely good viewing last night, that's for sure. Okay, so what are we doing today? Today we are, I obviously couldn't do I wasn't able to do the quiz makeup yesterday because I felt so terrible. So I'm doing it today at 2. Hopefully that gives everybody enough time to get home that's on the buses. We're going to, I'm going to demonstrate the actual lab with the ions, and then we'll call it a week and we'll move on. And you got a 3-day weekend coming up and the Super Bowl as well. So please, this is from Tuolumne County Health Department. And be safe if you're out there Super Bowling. And we're finally getting some decreases in our numbers, and I'll keep it that way. All right, now, because we have something culturally significant going on, I want to give you an opportunity to cast your vote. I thought I had put this in here. I guess I forgot. For the team of your choice, and then we'll come and talk about the actual lab we have to do. So I'm going to get the link for this if it ever shows up. There it is. I'm going to put this on an assignment and ask you to join our Super Bowl. Oops, that is not bowl. All right, so here's the link. Once that shows up in your feed, if you click on it, you'll come to this Jamboard, and you can, there's no points associated with this, sorry. I should have put ungraded. I'll fix that later. You'll be able to move a football to the team that you think is going to win or that you want to win, because it could be either one. So I thought we'd do something funny on Friday. So here is our Jamboard. Look at you guys go. Yeah. Hey, grab a football, Kansas City or Buccaneers. What are we doing? The Chiefs or the Buccaneers? What do you guys think? Or do you care? Some of us don't care that much, but especially if it's nobody from California, you know? Yep, so just grab one of the footballs and move it where you like. Yeah, I don't know if I want Brady to get another ring. I'm still kind of mad at him about the Deflategate stuff. So, you know, I don't know. I don't know. I'm cheering for the Chiefs. But, you know, hey, here they, we'll see, you know, it's always interesting. And then some people don't care. They put it on the 50-yard line. That's fine. Doesn't matter to you. I really dislike the commercials, but I guess a bunch of Budweiser's not doing their Clydesdale commercial this year. Oh, no. Sadness. The young lady that did the read her poem at the inauguration is going to be reading a poem at the Super Bowl, first one. That's pretty cool. All right, nobody's cheering for the Buccaneers? Wow, this one, who's that? Can't tell who that is. Who is that? Jaden? You're a Buck fan? All right. Okay, so that was just some silliness. I thought we'd do that because for some people it's a big deal, and it is part of our culture in this country. Okay, lots of above going there. All right, thank you for moving them all. Okay, we're gonna end that. Thank you. Thought it was fun. What the heck, you know? All right, let's talk about what you need to know for the lab. So when I wasn't able to be there with you yesterday, I couldn't do this with you. I have another Jamboard. So I just went ahead and gave you a copy from first period's work. You can't edit this. You can look at it though. And this is also a way that you can check all of your answers on your pre-lab data paper, or pre-lab question number 5. Right? So remember, ionic compounds dissociate when they go into water, which means they come apart. Okay? So sodium sulfate breaks into sodium ions and sulfate ions. And the way you can tell what they're breaking apart into is look at the capital letters. So when you're looking at this, and there's only 2 of you in here, but I guess you can see it on the screen. What we did in first and second, before I had my tooth yanked out, is we made little sticky notes. I've had people break them apart. So the first capital letter is N, and then there's a lowercase after it. That's the symbol for sodium. Sodium's in group 1, it has a +1 charge. This subscript 2 means there's 2 of them because sulfate needs 2 electrons. Okay? And then we broke apart the hydrogen nitrate, the sodium phosphate. Oops, I didn't want to do that. Let's get that back. So sodium phosphate, silver nitrate, lead 2 nitrate, potassium iodide. Each ionic compound that we're using dissociates, comes apart in water. Then we have free moving charged particles that conduct electricity, like you saw yesterday, and that are available to combine with other oppositely charged ions that they get mixed with. I guess I didn't explain that very well in the other classes. So this is now in your assignment feed, so you can check your answers. Remember, since nitrate is a -1 charge, and there's 2 of them, this is the lead that has the +2 charge, so it needs a Roman numeral 2. Chlorine or chloride ions are always -1. Since there's 3 -1s, that means this is the iron ion that gives away 3 electrons. Okay, so iron, Roman numeral 3, chloride. And we're gonna, on Tuesday, we're gonna look at, sorry, my tooth is hurting. We're gonna look at, missing tooth. We're gonna look at this in more detail on how to put compounds together. Okay, so you have this for reference, so you can fix up your lab. Okay, so this is the same table, and you can just type them in. And remember, the Chromebooks do control period to do upper exponents, okay, and you do control comma to do subscripts. This one. Any questions? And you have to do it again to get out of that. Any questions on how to do this? Everybody's good? Everybody knows how to do this? All right, don't be shy. Pipe in if you have a question, because somebody else probably does too. All right, well, here's what I'm going to do. I'm going to ask you to open this document up. It should have popped in for today. And then I'm going to switch and pin my phone. See if I have any better luck at this than I did yesterday. Or yesterday, oh my gosh. Earlier today. Okay, I'm going to stop presenting. And try this. Oh, heavens. What do you guys see? Do you see it? A shiny thing? Do you see me? Or do you see my white paper? Let's try this. You guys see the grid? Anybody? Yes, grid. Okay. So what I'm going to do is I've got my phone set up, and I'm going to show you how the bottles of solution look, and then we're going to put drops. I'm going to put drops onto this plastic sheet, and then on your table, that one, this one, on your table, you're going to write in what you observe. Now, I've numbered them 1 to 12. Don't worry about these numbers down at the bottom. That's for later, okay? They're going to correspond to these boxes. The gist of this is this anion, sulfate, and this cation, silver. I'm going to combine them, drops of liquid with them in there, and you're going to write down what you see. So from the pre-lab last night, you were supposed to define what an anion and a cation are. Hopefully you have that memorized by now. And then what does it mean to dissociate? That's the coming apart of the ionic compounds in water. Precipitate is when an insoluble solid forms. So lots of things dissolve in water, but lots of things don't dissolve in water. Thankfully, you don't. So when you take two solutions and put them together, sometimes you make something that's not soluble anymore, and it will cloud the liquid. And you'll see that in a minute. And then what you're supposed to do is fill this in, okay? So some of these don't do anything. Some of them have no visible reaction. NVR is a shorthand for that. And that's fine. Not everything makes something insoluble. Not everything makes it precipitate, okay? And yeah, we'll get to the bottom in a minute. So let me switch back here. Okay, and I'm going to fill down. So this is a dropper bottle. It's got some crunchy stuff. For some reason, sulfates grow mold pretty well, but it still works fine. It basically looks like water. It doesn't look like there's anything in there except some slimy stuff. So this column, box number 1 on your paper, the X's are here because some of the precipitates, a lot of them are white, and so trying to see a white precipitate on a white background is really difficult, and that is why the X is there, just so you can see that it clouds up. Okay, so I just put sodium sulfate drops there, and then this bottle is brown, and that's because silver nitrate is what we call photosensitive. So hydrogen peroxide also comes in a brown opaque bottle, and that's because it's also photosensitive. So the important thing when you're doing these is to notice that they look like water. So I just put 1 drop off to the side so you can see. Just, you wouldn't know there was anything in there. And then when I put the silver nitrate on here, it's probably really difficult to see because the light is not so good, but it's cloudy. Okay? It got cloudy. You can't see the black line as distinctly. I think if I turn on the light, this is going to have glare. So it's starting to get more white. Okay. I'm going to do the same thing with the hydrogen nitrate. And you just name the first capital letter. What is it? It's hydrogen. And then everything after it usually is the polyatomic ion, if there's more than one element. So this has hydrogen, nitrogen, and 3 oxygens. It's actually called nitric acid. Again, it looks just like water. I'm going to put some silver nitrate in there from the brown bottle. And no visible reaction. This one doesn't look like it does anything. Okay. And then the third column is going to be with the phosphate ion. Put that on there. Again, it looks just like water when I put it on there. However, when I put some silver nitrate in there, quite entertaining. And it is yellow. Okay? So you can tell that, oops, sorry about that, you can't see the black X anymore, and this precipitate is yellow. Okay? So white precipitate, NBR, yellow precipitate. And the shorthand for precipitate is PPT, like PowerPoint. Okay, so I'm going to do the same thing with the lead nitrate. I'm just going to go ahead and put the drops on there. There's lead nitrate. Can't see anything. This looks like water. So it's the lead 2 ion. What does it do with sulfate? It gets really cloudy. Okay, so this top one's faintly cloudy. This one's quite cloudy. Very white and cloudy. Do it with the nitrate. Nothing happens. And then the third column, the phosphate, number 6. Again, a white precipitate. Okay. So those are the anions, and reaction, the 1, 3, 4, and 6 all form precipitates. The only one with a color is this one. Okay, so we're going to do the same process with drops here. So what's happening is there's silver and nitrate ions in here, and there's sodium and sulfate ions in here, and then the positive can find the negative. Okay? We're going to learn about solubility rules later. Silver and lead are very often insoluble. Sulfates and phosphates are also highly insoluble most of the time. Okay. And I can get my bottles in the right place here. So the next one is potassium iodide. with sodium hydroxide. So sodium hydroxide is going to go across all of these. And again, it looks absolutely like water. You would never know there was anything in it just by looking at it. Potassium iodide. No visible reaction for number 7. Next one is calcium chloride. Notice I'm keeping the bottles up above so I don't touch the tips. And this one got cloudy and white. And then the last solution is iron-3 chloride, and it actually is kind of a reddish color, but I'll just show you it's clear. Okay, but when I put it with the sodium hydroxide, it makes a reddish brown precipitate. So NBR, white precipitate, red brown precipitate. Then we're going to go across the bottom. I think the original had ammonium thiocyanate. It doesn't really matter. I have potassium thiocyanate here. You can use either one. Again, it just looks like water, but there's stuff in there. Okay. And maybe potassium iodide. Nothing happens. With calcium chloride, again, nothing happens. It just looks like water. Iron chloride, iron-3 chloride. Whew, crazy. Super dark red-brown precipitate, almost black. So I'm going to go ahead and switch here. Again, this first one was a white precipitate, number 1. Number 2, no visible reaction. Number 3 was a yellow precipitate. 4 was a white precipitate. 5, no visible reaction. You might have noticed there was a middle row on my reaction sheet. That's because it's an extra set of reactions that the book says to do. They never work. So anyhow, I just stopped doing them, stopped trying. And then this one was a white precipitate, number 6. 7 was NBR. 8 had a white precipitate. 9 had the reddish brown precipitate. 10 was NBR. 11 NBR. And then 12 was that super dark, basically black precipitate. All right, get out of there. So the other things down below that you can do today is 2, 5, 7, 10, and 11. Just do NBR. We're going to talk about ionic reaction equations. And I'm going to show you one of them today, and then on Monday, Tuesday, I've been doing pretty good about that all day. On Tuesday, we will go over how ionic compounds form and finish up this reaction sheet. But let's just look at reaction number 1. Again, the silver is the cation and the sulfate is the anion. And we got a white, cloudy PPT. Okay, so PPT is a shorthand for precipitate. AQ, I think I've told you guys this before. AQ, anyway, AQ is for aqueous. Stuff that's dissolved in water is called aqueous. It's not melted. Okay, that's L for liquid. It's just dissolved in water. So one of the ions is the silver ion. And remember, control period gives you upper superscript, and then control period to get out of it again. Parentheses AQ plus. And then our sulfate ion is SO4 2 minus. So this one's a little trickier to type. S, big O, sub 4. So you use control comma. I have to do that again, get out of it. Control period for the superscript. Oh, I'm just doing that. Yeah. Okay. And this is also aqueous. So with the anion and cation combination, right, silver with nitrate is soluble, sodium with sulfate is soluble, and we'll find out that all the alkali metals are always soluble in water, and all nitrate compounds are soluble in water, but that's another story for another day. Do dash dash and the greater than symbol with a space, and you'll get a pretty arrow. This is going to go together, and it made an insoluble solid. And so what it made was silver sulfate. This is a +1. Silver contributes 1 electron, but sulfate needs 2. So we really need to have 2 silvers in here. And probably most of you look at that and go, why would you write that twice? You wouldn't. I'm just doing it for demonstration, okay? So silver, silver, +1, that means an electron left, +1, another electron left. Perfect, that one needs 2. Rather than write it twice, we don't do that, right? We're gonna put something called a coefficient in front, and coefficients are multipliers, okay? That coefficient tells you that there's 2 silver ions with 1 sulfate ion. The one's understood, we don't bother to write it. Don't write anything more than you have to, right? So AgAgSO, or you could write it like that, but of course, you know you don't write HHO for water, right? We're gonna get rid of this Ag and put a subscript 2, just like we do with water. It's 2 hydrogens and an oxygen. This one's 2 silvers and a sulfate. So what is that? That's name the first element, silver. Name the group that comes after, sulfate. And put PPT in parentheses. You could put S for solid, but this more clearly tells you it's in solution. Okay, and so we're going to work on completing the reaction equations for all the others on Tuesday. I'm so sorry I went right to the end. Have a wonderful rest of your Friday. Be good, be safe, and I will see you next week. If there's any questions, email me. If